Hey guys, just a quick review of everything we learned last week. We're going to do this one-step equations bell work just to jog our memory. We're coming back from a long weekend. We're going to want to remember all the things we talked about last week. So we're going to start by filling out these problems up here. Filling in the blanks is what I should say. So to solve an equation, use blank operations. We use inverse operations. And another word for inverse, or a word that is similar to inverse, is opposite. Addition and subtraction are inverse or opposite operations, whatever word you want to use here. And the inverse of addition is subtraction. So what that means, right, is we use subtraction to undo addition. And the reason we're undoing things is because our goal when we're solving equations is to get our variable all by itself. So we're going to do just this first example, and then I'll write the answers for the rest of them so you guys can check your work. But I'm just going to do the first example, then you can pause the video and try them out for yourself and check your answer. The first thing I'm going to do is draw a line down the middle so that I can see, hey, there's two sides to this equation. And this is a really important part for showing your work, which showing your work, you guys, is so important for solving equations. Even if these seem really easy to you now, you're going to get to a point that you're solving two-step equations and multi-step equations, and you're going to want to be able to show your work. So if you make a mistake, you can always go back and see where that mistake was made. Now, my goal is to get this x, which is the variable, all alone. And I've got to get rid of whatever's keeping it from being alone on that side of the equal sign. And right now, that's a +7. So to undo addition, we are going to subtract the 7. And remember, we have to keep the equation balanced. So if we take 7 away from one side, we have to take 7 away from the other side. So we're going to do that to both sides. When we do that, those 7s are going to cancel out to 0, and we are left with x equals 12 minus 7 is 5. Now, the next part of this says to check our work. And another word for check, and the word that we use in this class, is evaluate. So we're going to evaluate x equals 5. And we do that by plugging that 5 in for x to see if we did the math right, to see if our answer works. So now our equation says 5 plus 7 equals 12. Well, 5 plus 7 does equal 12, so we are correct. Awesome. Okay, the answers for the next ones I'm going to write down, but take this time, pause the video, try solving the rest of them on this page, and then come back and check your work. So we'll have z equals 8. M equals 3.61, and H equals 100. Those are the answers that you should have gotten. Moving on to the next page, the top part says the inverse of subtraction is, and we're going to fill in that blank with addition. In other words, we use addition to undo subtraction. So we're going to do 2 different examples on this page, and then you guys can pause it, practice on your own, and come back and check your answers. So we're going to solve first, and we're going to show our work every step of the way here. A is my variable, and I need to get it alone. Well, subtracting 5 is keeping it from being alone. So we're going to add 5 to both sides. Now, -5 plus 5, those cancel out to be 0, and we are left with A equals 8 plus 5 is 13. Now we're going to evaluate or check our answer. We're going to plug 13 in for A, rewrite our equation. Now 13 minus 5 is 8, so 8 equals 8. We are good. So pause this, do the very next problem on your own, and then come back and check. And the answer to that next problem should be x equals 4. We're going to work this next one together. There's an important different kind of idea here that I want to cover with you. And so we'll start working it, and I'll explain as I go. We're going to divide down the middle, right? And our goal on this problem is to get this W all by itself. Now, right now, that W has a negative sign in front of it, which means that the value of this right here is negative 1 W. And when we get a variable alone, we don't want it to be negative. We want the variable itself to be positive. So we're going to have to do a little extra step to move this around the right way. But we can start the same way that we've been starting and saying, hey, that positive 8 is keeping that W from being alone on this side. So we're going to subtract 8, keep our equation balanced, and do it on both sides. Now we have negative W, or negative 1W, equals negative 3. 5 minus 8 is negative 3. But again, we don't want this negative here. So we're going to have to come up with a way to get rid of it. And what we can do is add W to both sides. Now what that's going to do is cancel these W's out. So we're going to be left with 0 here. And negative 3 and W are not like terms. So on the other side, we're going to have negative 3 plus W. But now W is positive, mission accomplished there. We need it to be alone. So we're going to move the 3 to the other side by adding it to both sides. Remember, as long as I do it to both sides, you guys, I'm keeping my equation balanced, so it's not changing anything. We're going to cancel out those because they would be 0. So we're left with W here, and 0 plus 3 equals 3. So 3 equals W, which is the same as W equals 3. If we need to check our work by evaluating now, we're going to plug that 3 in for W, so we'll have 8 minus 3 equals 5. Well, 8 minus 8 minus 3 does equal 5. So we were correct. Now, all we had to do is that extra step to make sure W was positive. So pause the video, work the rest on your own, and come back to check your answers. We should have x equals 4, c equals 50, and x equals negative 3. Going on to the next page, we're switching gears here. We're going to multiplication and division. So to solve an equation, we use inverse operations, or opposite. And the inverse of multiplication is division. So we'll do one example on this, and then we'll move on, and you guys can try these on your own. So 6x equals 48. I'm going to split my equation into two sides. Now, remember that a coefficient and a variable written side by side means to multiply, so that really means 6 times x. So what's keeping x, my variable, from being alone here is being multiplied by 6. So to undo multiplying by 6, I'm going to divide by 6, and I have to do it on both sides. Now, 6 divided by 6 gives me 1. So those cancel out, and I'm left with 1x, which is just x. And 48 divided by 6 is 8. You can always check that on a calculator. So now I have x equals 8, What do I have to do to check my work? I have to evaluate for x equals 8. So I now have 6 times 8 equals 48. Well, 6 times 8 is 48, and that is true. Awesome. So let's do one more on this page. I want to do this one right here. Whoa, this one right here, just so we can talk a little bit about the negatives there. So we have negative 3x equals 12. Two sides to my equation. X is my variable here, and being multiplied by negative 3 is keeping it from being alone. So I've got to divide by negative 3. And the reason for that is, if you remember back to our integer operation rules, if you have a negative multiplied by a negative, you're going to get a positive. That rule works for division as well. A negative divided by a negative is a positive, and we need that x to be positive. So negative 3 divided by negative 3 is 1, so we're left with 1x or just x. And 12 divided by negative 3 is a positive divided by a negative. So the answer is negative 4. We're going to evaluate. So we'll have negative 3 times negative 4 equals 12. Well, 3 times 4 is 12, and because I have two negatives, my answer is positive. So 12 equals 12. We are right. Pause the video, try the others on your own, and then come back to it. Now the answers here, we should have m equals 0.7, h equals 0.9, and x equals -1/9. So guys, these are decimals. You may need to use your calculator to double check your math. All right, the very last page, here we go. So the inverse of division is multiplication. We're gonna I'll do two problems with you guys, and then you can try the rest on your own. So we'll start with this top one. We have x divided by 2 equals 12. Remember, this fraction bar just means division. So we could rewrite that as x divided by 2 equals 12. The fraction bar is how you'll see them most of the time, but you could rewrite it that way. They mean the same thing. We're going to divide into two parts here. Now remember that I can stick a 1 here. So now I have 1x divided by 2 equals 12. So x is my variable, and what's keeping it from being alone is being divided by 2. So we're going to multiply by the reciprocal. Multiply by the reciprocal. And reciprocal, if you remember, means to flip the fraction upside down. So we're going to multiply this by 2 over 1, because we had 1 over 2. We now have 2 over 1. The reason we're not bringing the x down here is we want the x to stay right where it is. We need to get it alone. We don't want to move it. And remember, whatever we do to one side, we have to do to the other. And we do not want to get an x over here on this side. So we're not going to bring it over. When we multiply fractions, we multiply straight across. So 2 multiplied by 1x is 2x, and 1 multiplied by 2 is 2. Well, 2 over 2 cancel out, and we're left with x. Now on this side, if you think back to fractions and the rules, 2 over 1 just means 2. But if you want to keep things as fractions, you can always change this into a fraction by making it 12 over 1. Means the same thing as 12. Any number over 1 is just itself. So I'm going to change them to a fraction just so we can see what it looks like and what's happening. But if you don't, that's totally fine. Now 12 times 2 is 24. And 1 times 1 is 1. So x equals 24. Now we're going to evaluate or check our answer. So we're going to plug 24 in for x, and so we have 24 over 2 equals 12. If you punch 24 divided by 2 in a calculator, you will get 12. So we're correct. Awesome. Now pause the video and do these two on your own, and then come back and check your answers and we'll move on. So here we should get A equals 35. Here we should get M equals negative 15. Moving on down here, we have some decimals. And I just want to do one example with the decimals so you guys realize they're just numbers. We don't need to be afraid of them or freaked out. So divide our equation down the equal sign. We're going to put a 1 here just so we remember that it's there. We can drop that 1 and add that 1 in front of variables that are alone all the time. Doesn't change the value. So now we have 1x divided by 2 equals 1.2. We're going to undo dividing by 2 by multiplying by 2 over 1. Multiplying by 2 over 1, which just means 2. When we do that, we get 2x over 2, and those cancel. We're left with x. And 1.2 over 1, if you want to keep it as a fraction. When we multiply with a decimal, we can still just punch it in our calculator. 1.2 times 2 is 2.4. 2.4 over 1 is just 2.4. So we get x equals 2.4. Now to evaluate, we're going to put 2.4 in for x, divide it by 2, and see if it gives us 1.2. Oh, it did, so we are correct. Okay, I'm going to give you guys the answers to these last two, but before you look at them, pause the video and then come back to check your work. We should have A equals 32.5 and M equals negative 16.2. That is a quick refresher for how we solve one-step equations. If you guys have any questions, just reach out and let me know.